radian measure of angles. So by the end of this video, you should be able to compare between degrees and what radian, and how to find the coterminal angles, and to find the complement and the supplement angles. Alright, so let's start with the radian measure. We know that an angle with 8 vertices at the center of a circle and terminal side that intersects an arc on the circle equal in length to the radius of the circle has a measure of 1 radian. Alright, so make sure you take note of that. So what we mean is this. Alright. And we have the angle here. Okay. This is the radian. Alright. And that is that. So we also have the y-axis and that. Alright. So what does it mean if an angle has a radian measure of 2? So what we mean when an angle has a radian measure of 2 is that the terminal side of the angle intersects an arc equal in length to the twice the radius of the circle. So in general, if theta is a central angle of a circle of radian arc and each terminal side intersect an arc of length x, then the radian measure of theta is equal to s over r. It's equal to s over r. Since s and r have the same units, radian measure is unita. Alright, so then what formula can we use to represent an arc or a length? Alright, so what this S means is that this S represents arc length. This S represents arc length. And if the angle is equal to S over the R, then the arc length will also be equal to theta times the radius. Alright, make sure you take note of these concepts for me. So now let's see how to convert between degrees and radian. Let's see how to convert between degrees and radian. Alright, let's continue. So let's go to converting between degrees and radian. We are going to see how to convert between degrees and radian. So let's move on. An angle of 360 degrees is equal to 2 pi. An angle of 360 degrees is equal to 2 pi radians. An angle of 180 is equal to pi radians. So using 180 degrees is equal to pi, then 1 degree is going to be equal to pi over 180. And we are going to get 1 degree. Because we know that pi is 180 and it is 180. So with that we get a radian. Alright. And multiply a degree. Take note. Multiply a degree measure. Multiply a degree measure by pi over 180 radian to compare to degrees. So that means that if you have an angle in a radian measure, to compare to degree, you multiply by pi over 180. Alright. 2. If pi is equal to 180, then 1 radian is equal to 180 over what? Pi. 180 over pi. And multiply a radian measure by 180 over pi to compare to what? Degree. To compare to what? Degree. So that is all what we want to say here. Let's look at an example for you to understand what I'm projecting to you very well. Alright. So looking at our first example, convert one. Example. Convert A 45 degrees, B 135 degrees, C 15 degrees, 2 radians. Alright, 2 radians. Straightforward. Let's move on. 2 radians. So if you have this, you have 45 degrees and you want to convert to radians. What we are saying is that just multiply by what? Pi over 180. Pi over 180, and that's exactly what I have put in here. Pi over 180. And when you do that, we are going to get pi over 4 rad. That is radian. Alright. B. If you have a degree 135 and you want to convert to radian, you multiply by pi over 180. Alright. And doing that one too, we are going to get 3 pi over 4 rad. 3 pi over 4 rad. Make sure you punch on the calculator. Hope you know where you can locate in the pi. Alright, C. Okay, 15 degrees. 15 degrees. That one to multiply by pi over 180. Alright, and write whatever it's going to give you. And that is pi over 12 rad. Alright. Very good. 2. Let's look at our second example here. Convert example 2. Convert negative pi over 2 B pi over 4 to degree measure. And that one we multiply by, so when you take negative pi over 2, you multiply by 180 over pi. And the idea is that we want to get degree measure. That means that we have to get rid of the pi. So you divide by something that can clear out the pi inside. And you are going to get negative, only going to negative 90 degrees. Negative 90 degrees. So that is that. Alright. Secondly, try the second one. Pi on 4. Pi on 4 multiplied by 180 over pi. This will clear up this. When you divide that by 4, what are you going to get that? And that is 45 degrees. 45 degrees. Alright, so let's look at some applications. Or before that, let me see something. Okay, let's look at this question. Find the exact value of let me add one more example. 3. Find the exact value of 2.249.8 degrees. So to find the exact value of this is just simple, alright? So we do it in the same way. We know that this one is in what? Degrees. So the same as we convert it to a radian, alright? But here we want the exact value. So because of this word, something will come in here. So 249.8 times pi over 180, alright? So when you do that, you are going to get it in the, you leave it in decimals, okay? And that is this. That is the exact value that we are talking about. Even if you punch and you get a pi inside of it, make sure you resolve it into decimals, alright? So that is that for that. Now, let's look at one application question here. A circle has radius. A circle has a radius 18.2 centimeters. Find the length of the arc intercepted by a central angle having the following. A, 3 pi over 6. B, 144 degrees. Alright, so what you are projecting to you here is just simple. Anytime students hear of application question, then they start panicking. Alright, we know that the arc length is equal to theta over what? R. Alright, good. So we say that a circle has a radius of what? So we know that the arc is 18.2 centimeters. Alright. Find the length of, that means that we are looking for the arc length of the arc intersected by a central angle having the following. That means that now this A given you here, this is representing the theta, which is 3 pi over what? 6. That is representing what? The radian. Alright. So to get the arc length, you just multiply 18.2 by 3 pi over 6. And what is that going to give you? That is 21.4 centimeters. Alright. So that is going to be the arc length. Okay? Try on the second one, 144, and see what you are going to get. Alright. So we are done with that. Let's go to our next objective, that is coterminal angles. Coterminal angles. so all that we are going to do at coterminal angles is so simple. Alright, let me introduce something nice to you. Angles A and B are coterminal. We are saying that we say angles A and B are coterminal. If they have the same initial side and terminal side. Example, 0 degrees and 360 degrees. We are saying that two angles, let's say A and B, are coterminal if they have the same initial side and what? A terminal side. You know what we mean by initial and terminal. Like if we have this angle here, the initial starts from here and this is the what? The terminal. So we are saying that if they are having the same initial and a terminal side, that means that they are what? Coterminal. So looking at example like 0 degrees and 360 degrees. And 0 degrees, here we have this to be a 0 degrees. Alright? And 360 degrees to up to this side. And this one too is 360 degrees. So we have 0 degrees and 360 degrees. They are of the same terminal side. They are of the same terminal side. So we can say that they are co-terminal. They can say they are co-terminal. Alright. So in general, this is what we mean. Okay, so we have angle A here. We have angle B from here to here. Hope you can see that. And this is the B. So this angle A, we don't care whatever the angle A is. And this angle B, they are coterminal because they all have the same terminal, right? They all have the same terminal. Okay. We can also have an angle represented like this. We can also have something like this. So from here, the angle from here to this, and angle from here to here, no matter the value, of the range, it is still coterminal. It is still what? Coterminal. So what this means is that to get this B, to get this angle B, we have to subtract 360 from what? A, in order to get this angle B. Because we know that one revolution from here to here is one revolution, and that is 2 pi or 360 degrees. So to get this A is we subtracting 360 from what? This A, and that will help us to get the what? The B. I hope it's clear there. Alright. Having this, what are we going to do to get this B? This B is more than one revolution. It's from here to this. So to get that, we have to add 360 degrees plus the what? Plus the A. Because from here to here is the 360. and it has gained another what? Angle, and that angle is what? A. So we add the 360 to the what? To the A. Alright. Good. So let's look at our first example. Find the complement. Find the complement and the supplement of the following angles, if possible. Make sure you write. Find the complement and the supplement of the following angles, if possible. If possible. And the angle is pi over 3. Pi over 3. Pi over 3. Alright. Pi over 3. Now, we know that pi over 3, the angle is pi over 3. And pi over 3, if you want to, in case in radian, you are not well getting the value, you convert to degree, you see that when you convert to degree, that is multiplying this by what? 360 over pi. And that's going to give you, 180 over pi rather. 180 over pi. And that's going to give you 60 what? Degrees. So pi on 3 is the same as 60 what? Degrees. That is pi on what? 3. So this angle is pi on 3. Very good. So to find the complements and the supplements, you know what a complement means, alright? When an angle adds up to what? 180, when an angle up to 90, they are what? Complement. And when an angle up to 180, they are what? Supplement. So to find the complements, we are saying that when it adds up to 90 degrees, it is complement. That means that to find the complement of this, we have to, and here it was given to us in radian. So it's going to be the radian measure of pi on 2, which is what? 90 degrees minus pi on 3, and that is going to give us pi on 6. Pi on 6. Alright, so that is for the complement. Let's come to supplement. Alright. Now, for supplement, it adds up to 180. So to get that, you subtract this from it, pi on 3, and that is going to give you 2 pi over 3. 2 pi over 3. Wow, love it. So that is how it is. So you can give yourself examples and try your hands on it. Alright. Let's look at this second example 2. Find the coterminal angle of the following. Find the coterminal angle of the following. Right, make sure you write it too. Find the, we are in class. Find the coterminal. Find the coterminal. Find the coterminal of the following. And the A is pi on 12. Pi on 12. Alright. Pi on 12. Let me give up to you. The B is pi on 4. And the C is 17 pi over 6. 17 pi over 6. Very good. 17 pi over 6. So try out on it. Alright, let's continue. So looking at the first example, now here there is a need for you to sketch it, alright? You need to first sketch it. To know the quadrant it falls. Knowing the quadrant it falling is very, very necessary as far as this course or this coterminal is concerned. So 90 degrees is, I don't say pi on 2, which is 90 degrees. This is pi on 12, alright? So it is helpful for you to convert to degree, because pi on 12 may not sound well for you. So let's convert. Multiply by 180 over pi. 15 degrees. So this is the same as 15 degrees. So you will know that 15 degrees is here. Here is 15 degrees. Alright. So knowing that this is 15 degrees. Alright. Then, to get the coterminal is that we are looking for the angle which is what? Tell me. Which will be having the same initial side and a terminal side. So we want the angle that will be the same as from here to here, and also from here to here. So what am I doing? Something like that. So simply, like what you first discovered, what you do is that you take 2 pi, since it's in radians, alright? You take 2 pi plus or minus pi or what? 12. And that is just going to give you the what? The coterminal. That's just going to give you the what? The coterminal. Alright? So, sorry. First of all, you add this by 2 pi. Then you subtract this from what? 2 pi. So it's rather pi on 12 plus or minus 2 pi. Yes. That's what exactly I was wanted to write. Okay, so here we are going to get 25 pi on 12. And here we are going to get negative 2, 23 pi on 12. So that is what exactly we are going to have. So it's just taking pi on 12 plus or minus 2 pi. In the same way, the b. The b also, we are going to do it in the same way, alright? So you can now continue. The b, take pi on 4 plus or minus 2 pi. The b, the c, take 17 pi on 6 plus or minus 2 pi. But bear in mind that if it's given in a degree, make sure you don't use 2 pi, but rather use what? 360 degrees. Alright, so that is that for that. That is that for that. So you can now compute it and go your way. You can now compute it and go your way. Okay, so that is all for that. In our next video, we are going to look at trigonometric what? Functions. Trigonometric what? Functions. Make sure you read on it or watch out for the next video. Bye bye.